Conventional layer palletizers have been around from the late 1940s. And although the basic principles remain the same, technology has evolved over the past years. And even though robotic palletizers may seem more modern, the layer palletizers often remain a reliable and flexible choice. The heart of every palletizing process is the layer formation. This module determines the speed, accuracy, and flexibility of the overall palletizing machine. And thanks to many improvements, they meet the ever-growing complexity of the market. Successful layer formation occurs when the system can create various patterns, ensuring that the outer side of each layer is perfectly aligned. This provides that the maximum strength of the cardboard is utilized, such that the stack generates inward pressure, resulting in the sturdiest pallet load possible. This film showcases the evolution of palletizing and the way Qimarox has mastered the process of layer formation. In the early days, boxes were fed into the system in a single direction. When a row is filled, it's pushed against the previous one until the layer is complete. Next, the layer is placed onto the pallet. With this type of layer formation, the possibilities of the box geometry are very limited. Furthermore, due to carton tolerances, boxes are never the same size. Since this system cannot account for this variability, the outer alignment is not completely straight. As more packaging designs were developed over the years, there was a need for more flexibility. That's why the option of rotating the boxes was introduced. Using a retractable cam, boxes can be rotated, allowing for a broader range of layer formations. It's a simple yet powerful solution. However, it falls short at times. Due to the positioning of the cam and the roughness of the boxes, the rotation can go wrong, leading to an unstable pattern formation. Especially in processes with varying product dimensions, where the cam is manually adjusted, disruptions often occur. Additionally, the impact with the cam damages the boxes. To further increase the layer formation possibilities and to handle different box dimensions, stoppers were added. These mechanical stoppers create very accurate spaces between individual boxes. The usage of cam and stoppers is a very hands-on method for more formation options, which increased pallet stability. However, its flexibility is limited. Not all box dimensions can be palletized. Also, the variation in box dimensions and quality often cause formation errors. To tackle this, PLC sensors were introduced. On the metering belt, the box is scanned and based on timing, spaces are created. This increases the flexibility, since the system can easily work with different box dimensions and is able to handle small boxes as well. The downside is that when a box passes through the PLC sensor at an angle, the measured length doesn't correspond to the box size. And when pushing a wrongly rotated item, the location of the spacing shifts. Moreover, the robustness of the system is decreased compared to a fully mechanical system. Also, the usage of PLCs does not offer a solution for the limitations of the cam. The manual positioning of the cam requires precision, and the PLC code takes several milliseconds to run. This often results in inaccurate spacing and insufficient turning, causing crashes in the layer formation. The introduction of the robot arm opened unparalleled flexibility, enabling work with a wide range of products and layer formations. However, it often involves numerous unnecessary mechanical movements. The initial models placed items one by one, moving from and to fixed coordinates, and thus not taking into account box tolerances. This resulted in unstable pallets. Moreover, the gripper causes unwanted spaces, is often dimension-specific, and because of the fall height, the risk of damage to products or packaging is raised. Due to its cycling time of several seconds, this robot arm has limited capacity. Therefore, nowadays, preforming is often employed with robots as well. However, with the use of stoppers or PLCs, the flexible advantage of a robot arm is immediately lost. Even with a robot, preforming is possible. Unfortunately, this results in reduced capacity, and incorrect timing of gripping leads to incorrect formations. That's why it remains highly regarded by major users in the industry that layer palletizers are by far the best systems. In last decades, the unique and patented layer formation module in all our palletizers combines the flexibility of a robot with the reliability of the layer formation stations. In the basic version, we use an integrated cam on the forming slide. This allows us to accurately position the cam. Alternatively, turning of the products can be done by an advanced twist runner module. It is the only solution that enables rotation in a flow, contactless. This reduces the risk of damaging items. Moreover, all labels can be placed facing outward if required. We also offer the TR6, which has an additional set of lights curtains. These continuously measure the product during turning, correct for slip, and ensure an exact rotation of the products. All positioning is done in the roller deck, assuring secure and safe location of the products, since no picking is required. Where many other systems feed products orthogonally, we do this from an inline direction. As a result, we are not limited by the maximum width of a machine. The consequence is that we have more margin for spaces, and therefore offer more flexibility to create complex layer patterns. The spacings can measure up to 5 to 10 centimeters in both the horizontal and vertical directions on the forming lane. This is crucial because complex patterns require more gaps during formation. These gaps ensure that all boxes can slide past each other flawlessly. Additionally, variations in rotation and box dimensions are no longer problematic. This makes our machine incredibly forgiving, as we say. It also absorbs tolerances in cardboard packaging and product items in the pattern. This layer formation method ensures that the outer side of each layer is perfectly aligned, resulting in a sturdy pallet load. And as the whole process is monitored, any delay in the process is quickly detected to avoid further problems. Virtually any layer pattern can be created through a PC or the HMI, without any additional programming required. The process can even be fully automated to create layer patterns on the fly. This allows format changeovers in production at any time. The palletizing solution is equipped with intelligent control and real-time measurements. It opens possibilities for smart data analysis and transforms the palletizing solution into a self-learning machine, enabling Industry 4.0 and increasing the overall OEE of the system. Combined with the small footprint and no production stops thanks to fully automated change and layer recipes, the Qimarox Palletizer is the perfect end-of-line solution for all logistic challenges.